So let's talk about exponents. So we're in section 4.1 of the book, Rules of Exponents. So let's first briefly just talk about what an exponent is, right? So if I have, let's say, a to the fifth power, right? And so terminology, the a is the base of the exponent, right? And the 5 is the exponent, sometimes called the power, right? All right, so what does an exponent do? So let's go back to multiplication for a second. So we know that 3 times 4, 3 multiplied by 4, what that means is that you can add 3 to itself 4 times, right? So that's essentially what 3 times 4 does. So if I have 3 to the 4th power, what that does is what that means is you multiply 3 by itself 4 times. All right, so just like multiplication is a shortcut to addition, exponents are a shortcut to multiplication. All right, so the exponent tells you how many times, how many times to multiply the base, right? Or how many of this number do you have in the product, right? So you have a product of 4 3s in this case. All right, now a couple other terms. This is called expanded form of an exponent. And this is called exponential form. All right, so, and we'll come back to expanded form to kind of help us to make sense of some of the rules that we're going to talk about of exponents. All right, so our first rule is the product rule. So the product rule says if you multiply bases, and they have to be like bases, so notice that the bases are the same, right? So if we multiply like bases, then we can add the exponents, okay? So the exponent of this first exponential expression is m, and the exponent of the second exponential expression is n. So what I can do is I can combine where I have one single base, okay? And notice the base stays the same, right? It's still just a, and then I just add the exponents. All right? So here's an example. If I have 5 to the 4th times 5 squared times another 5 to the first, right? Invisible 1 there. Then I can just add the exponents together. So I can add 4 plus 2 plus 1, and that gives us 7. So instead of writing this, I can write this, right? So that's another shortcut. So let's see how this works. So what I'm going to do is I'm going to convert these to expanded form, right? 5 to the 4th is 5 times 5 times 5 times 5, right? So I have that multiplied by 5 squared, 5 times 5, multiplied by 5, or 5 to the first power. And so really essentially what I have is I have a product of 7 5s, right? And we know that that's the expanded form for 5 to the 7th. Okay, so that's how the product rule works, is basically instead of writing out an expanded form, or just multiplying all those on your calculator, you can just add those exponents together, and that'll be your new exponent. Okay. All right. Now, one thing to watch out for. This only works once again when your bases are the same. So these are non-examples. These are things not to do, right? So don't do this. If you have 2 cubed times 3 to the 4th or something like that, that does not equal 6 to the 7th, right? Or something like that, because these bases aren't the same, right? So the product rule does not apply to that situation. So if you're wondering how you would do that, what you'd have to do is you just have to expand 2 to the 3rd, or simplify that. That would be 8. 3 to the 4th would be 81. Then you'd have to multiply 8 times 81, and that product would be, or that result would be your final answer. Okay, so that's one thing not to do. All right, the other non-example that I want to show you is also a common misconception. It's where let's say I have 2 to the 3rd times 2 to the 5th, right? Sometimes people try to multiply their bases and add the exponents, and that doesn't work. So this is not going to be equal to 4 to the 8th, right? So be careful with that, right? This would equal, what it should equal is 2 to the 8th, okay? So remember, if I expanded these, I would have 3 2's, right? And 5 2's. So altogether I'd have 8 2's. I wouldn't have 8 4's, a product of 8 4's. I'd have a product of 8 2's. So watch out for those misconceptions there, okay? All right. So here's some practice with our product rule. All right, so remember the product rule says that if we multiply bases that are like bases, let's go back to that for a second, right? Then we can just add the exponents,